So today I'm going to be doing a two-sample mean problem, mean confidence interval. And I'm going to be using this problem right here. It says, do plastic bags from Target or plastic bags from Bahash, I don't know if that's Bahas, hold more weight? I think I'm just going to use Meyer. We'll just talk about Target and Meyer. A group of AP Statistics students decide to investigate by filling a random sample of 5 bags from each store with a common grocery items until the bags ripped. Then they weighed the contents of items in each bag to determine its capacity. Here are the results in grams. So something just to be on the lookout for is that it does kind of look like a matched pairs problem. The only issue is that these two things do not match up. There's no specific order. This, they put 12,572 grams in one and 9,552 in another. This has nothing to do with each other. In fact, I could just completely mix these up and put the 11,000 across from the 9,000. It won't matter. So we have to keep these samples completely separate. So this is a two-sample mean problem. So let me get, let's see here. I'm going to enter this in my calculator, so if you've not already started, enter in L1 and L2. And so you'll notice that in L1 and L2, I have my data right there. You'll also notice that I'm going to have to do stat calc one variable statistics twice to grab the information. So I'm going to do it on L1, and then I'm going to do it on L2. So if you need to pause this or anything to make sure that this gets entered in everyone's calculator, 5 samples from each, kept separate. I'm not going to be using L3 in this scenario. 2 samples kept separate. Okay, so stat calc one variable statistics on L1 will give me the mean for Target and the standard deviation. So I'm going to copy that down right now on my paper so I can get that, and then I'll show you guys. So X bar of Target is 12825.8. The standard deviation, I'm always choosing the letter S. I know that's weird, but whenever you're given the choice in the calculator, always choose the S, 1912.5. And N is equal to 5. Okay. And then I'm going to do the same thing for I'm going to call it Meyer, even though it's Bash Hash. So this will be X bar of M. So I'll do stat calc one variable statistics, L2, and I'm getting 9234, and S is 1474, and N is equal to 5. So for 2 samples, you don't even have to have the same sample size. I mean, I could go to 10, do this 10 times for Target and 5 times for the Meyer, and you can still do a 2 sample because they're not lining up with each other like a matched pairs is, where you can do a subtraction of each individual individual piece. So let me back up and show you what I've got on my piece of paper. That out of the way. Okay, so I am doing a confidence interval, and the book is actually asking us for a 99% confidence interval, so that's what we will go about doing. When you're doing everything, you have to make sure that you, at the very least, define your variables, the Greek letters. So let's define our variables. And I'm also going to need to know the difference, because that's going to come into play whenever you're doing any comparison of two things. You're going to have a difference. So let's do that. So we'll have, I'm going to take larger minus smaller. So we'll do x bar of t minus x bar of m is equal to 1, 2, and I'm getting 3591.8. And that is the difference in my sample proportions. Okay, so let's make sure, so this is going to be used when we go to our curve and try to figure out what's going to go on that curve. We're going to be using that. So make sure you have that. Okay, so let's define our populations of interest. So we have our mu of t. We don't know what it is, but it is the population mean capacity of plastic bags from Target. Sideways, and we'll have mu of Meyer is the ditto population mean capacity of plastic bags from Meyer. Okay, so I don't have to put words near everything else, but you better make sure that you have them for the populations. So now let's go to our conditions. So conditions for a 2-sample mean, and means are t because we don't know what sigma is from each of these samples, because these are both samples, so we don't know what the true population difference is. So conditions for a 2-sample mean, t confidence interval, and if you're on a t distribution when you don't know sigma, you're going to use, you're going to have degrees of freedom. Now this is going to be a little weird, but we're going to write with calculator degrees of freedom. And I'm going to come back and eventually we're going to fill that in, whatever the calculator tells us. So for one sample, it's just n-1. For 2 samples, there's a complicated formula that you are not responsible in using. So we're just going to have the calculator give us the degrees of freedom here, and then I'll show you how to handle that when we get down to the formula. But you do have to specify what degrees of freedom you're using. I highly recommend using the calculator because that's what I'm going to use in the end when I go to the test menu. So number 1, are they independent? We're going to put some independent simple random samples from the population of Target bags, and likewise the others. So you have to do everything twice. So independent, make sure you write that word when you're doing 2 samples. Simple random samples from the population of Target and Meyer bags. And I'm just going to look back at the problem. It looks like they did take a random sample. So notice I'm doing 2 populations. Number 2, we have to check that the population of Target bags and then the population of Meyer bags are both greater than 10 times n. Okay, so N for Target, N for Meyer, they are the same, so they both have to be greater than or equal to 50, and I would say definitely a yes here. We've probably got more than 50 bags in my house right now. Therefore, we have independent bags. Okay, so now I get to the third condition, and this is always the one where you kind of have to stop for a second and think, okay, are we at a mean or a proportion? If you're ever given data in your calculator, you know it's a mean, so there's not really much to think about there. Now I go to the conditions for means, and let me bring this up again. I have this typed up from a long time ago. We have two different populations that we're worrying about. So the two different samples, we need both of those populations to be normally distributed. So, I go back to this, the third conditions for t distribution, and the population is not normally distributed. You might never know that again. Our sample sizes are way too small, unfortunately. We're looking at a pretty small one, so we want a distribution that doesn't have any skewness and no outliers to be able to continue. So we're going to have to check that for both of them. So I'm going to say N of Target is less than 15, and the N of Meyer is less than 15. So let's look at the box plots, and then we'll comment on those box plots. So right now I have my data in L1 and L2. Go to your plots, which is under the y equals. Now right now I'm going to turn two plots on. So for plot 1, make sure your list is L1. Then what I can do is go back in and go to plot 2, turn plot 2 on now, and set that for L2. So guys, remember, when you have these two plots turned on, you might get an error later on when you're trying to do something. So, when you get done, turn the plot off so you don't have two plots on, because it won't recognize the data if you don't have it in both of them. So I'm going to do zoom 9 stat. And we're going to take a look at the top one is the Target, that's L1, and the bottom one is the Meyer. And there's very slight skewness, no major outliers. I'm okay to move on. So copy both of these, just a sketch of these two box plots, and talk about it. Okay, and I'll set, both box plots. Have very slight skew and no outliers. We're going to proceed with the T procedures. So down here I'm going to say, therefore, a T approximation is okay. Okay? So everything you're just doing twice. Now I can go, so I am on a confidence interval, and I'm going to draw my normal curve because number 3 has allowed me to do that. So I go here. Now remember, if you have the Greek letter, that's what goes in the middle, but unfortunately we don't have the Greek letter. We have two different sample means, and what we want to look at is the difference of those two sample means. That's what's going to go in the middle. That's the statistic. So this is going to be your 3591. Okay, and let me move that up. That came from doing the subtraction of your two sample means. That's how I got the 3591.8. So that's what's going to go in the middle. We're going to do a 99% confidence interval, because that was the problem was asking. You guys never really saw that. So this is 0.99, and our job is to find out what do we add and what do we subtract, our margin of error, to get those two numbers. So we start in the middle. It's going to look ugly, but here we are, guys. So, confidence interval formula. Statistic, the difference, plus or minus t star, times the standard deviation of the statistic. Come right down here. 2 sample. Mean. This is your formula you want. Okay. We don't know sigma, so we're going to have to use the standard error. We're going to have to use S's instead of the sigmas because we don't know those. Okay, so you'll notice my formula. X bar target minus X bar Meyer plus or minus T star times the square root of S squared from target over N of target plus S squared from Meyer over N of Meyer. Formula. Substitution. 3591.8 plus or minus. Now, the T star, normally we would be going into our Lime sheet, and I think it's page 16, and we have to find the degrees of freedom. But in this scenario, we don't know what the degrees of freedom are. We're going to get that from the calculator. And because it can't be exact, we're just going to leave the T star, we're not going to fill it in. We're just going to leave it there. Because if you fill it in with something, and then your answer doesn't match what we get from the calculator, they will mark you wrong on that. So it's better just to leave that T star because we don't know the degrees of freedom on a 2 sample mean. So T star times, and I've got, what do we have? 1912 squared plus okay, now we go to the calculator. Stat test. We're doing an interval, 2 sample, and it's not proportion, so please do not use, it should be pretty obvious, 2 sample t, and means are almost always t's. It'd be very rare for us to know the population standard deviation of the of the capacity of bags. So I'm going to do 2 sample t interval, and I have my data. And now make sure that you're doing larger minus smaller. Target came first and just so happened to be the larger poundage or kilograms, whatever it was. And then so that's L1, and then L2 is there. Don't worry about frequency. 99%, 0.99. Now what's interesting is they ask you about pooling, and the only time you're ever pooling is on a 2 sample proportion significance test. And when you're supposed to pool, they don't ask you about pooling. So if the calculator ever asks you to pool, just say no. You'll never pool. The calculator, when you're supposed to be pooling, it'll do it automatically. So there we are, and hit calculate. And this is the interval that, again, we've got our degrees of freedom, so come on up here and just copy that down, 7.51. So that goes up in the title. Don't forget to write down the calculator degrees of freedom. And then we'll copy down our confidence intervals. So negative 100.9, comma, 7.284.5. Wow, it's a big confidence interval. $7,284.5. Okay, so here we are. Let's interpret our confidence interval. Always interpret a confidence interval if you're ever given one, whether you had to calculate it or not. We are 99% confident the true population mean difference in the capacity Target and Meyer bags, and you can just show them how you subtracted, is between negative 100.9 and 7284.5 grams. Means will have units on them. So this is it's somewhere in here, the true population mean difference. Make sure it's about differences. If I was doing a significance test and I was trying to figure out, is there a difference between these two things, I can tell you right now there would be no difference, because this 0 is in the interval, so the difference could potentially be 0, where there is no difference between the two bags. So very wide interval, and and it does include 0, which means there's not really much of a difference. But so this is a confidence interval for that. Okay, guys, you guys have a good day, and hopefully everything's going well. See you in the next video.